Okay, one final example, and that is this one's a little more complicated. The magnitude and direction exerted by two tugboats towing the ship. So, uh, um, let's pretend the ship is here at the origin. I have two tugboats, one up here and one down here. 1,610 kilograms. That's the 1610. That's this U, vector U. North 35 west. So you see, this is a little confusing. This is the way it's written in the book. But what this means is you start north, and then you go 35 degrees to the west. It really helps to draw a diagram like this. I would really, really, really recommend it. So you start north, and you go 35 degrees west, and so that's what this 35 degree angle is here. And there's another tugboat that's 1,250 kilograms, and that's 55 degrees, again, west of south. You're starting south, and then you're going 55 degrees to the west. Start here, and we're swinging along 55 degrees here. So find the magnitude and the direction angle to the nearest tenth of the resultant force. So there's going to be, if I add these two forces, I'm going to get a resultant force that, well, it's going to be, this is about halfway between, and of course this is a little stronger, so I'm thinking, maybe that's halfway and this one's a little stronger. So I'm thinking something maybe in that direction. I don't know if the magnitude is accurate here. I'm just eyeballing it. It's probably a little stronger than this. But you get the idea. It's going to look something like this. So first, again, I'm going to call this first one U and this one V, and we can even call this W. W. Oh. Okay. Anyway. Okay, so let's see how this works. If I'm going to add two vectors, I have to separate the vectors into their components first. You add the I terms, you add the J terms. That's how you add vectors. So I have to write this. I'm going to write my vector U as follows. I need to separate. It's 1,610, but this is not up or down. This is at a slant. So I'm going to write this as 1610, and the x direction. Remember, x is associated with cosine. Now, cosine of what? Well, I'm going to base everything based on the origin. So I'm going to look at it we're just going to call this due east. We're going to call that 0. That's the general convention that the book uses, so I'll use that here. So it's 90 degrees here, plus an additional 35 degrees. That's a total of 125 degrees. So I'm going to make it 1610 cosine of 125, and that's going to be in my I direction. And 1610 sine 125 degrees, and that's in my J direction. Okay. So that's vector U. It's separated into its component parts. I got to do the same thing for V. Well, this is 1250. And 1250 sine. Now, cosine and sine of what? Well, let's see. It's down here. 55 degrees here means an additional 35 degrees here. So these add up to 90. So 35 plus this 180 gives 215. 215 degrees high. Okay. So now let's add these. You can put these into a calculator, and I've done this ahead of time. 1610 times the cosine of 125 degrees is going to be minus 923 is what I have here. Plus 1,319J. I probably shouldn't round these off as much, but And this makes sense. I mean, it's a negative 923, so it's definitely negative in the x direction and positive in the y direction. So that's this u vector in its component parts. Did the same thing for v, and again, basically we just put this in the calculator. 1250 times cosine of 215 degrees is going to give me minus 1024, and 1250 times sine of 215. It should give us. It will give us negative 717j, and of course, this is negative in both the x and y direction. The v is, so that makes sense. Okay, so now we're looking at the resultant vector. I can add these two up to get my result. So, I think I said w is u plus v. And again, just going to add these two. 923, 1024. This gives us minus 1947 I plus 602 J. Okay. So that's our resultant vector. That's what this is going to be right here. Negative 1947, positive 602. So you can see, kind of. All right, so we need to finish by finding two things. We need to find the magnitude and direction. Okay. Well, the magnitude, you need to find the magnitude of W. Well, what's that going to be? That's going to be the square root of 1947 squared plus 602 squared. I know I used positive 1947. Look, if I square it, it's going to come. This is going to come out positive anyway. So I'm just trying to save a few pen strokes here. If I do that, it comes out to 2,037. 2,037 kilograms. So that's the magnitude of this force. This makes sense. If I add these directly, 1610 plus 1250, I get about 2,800. But of course, they're not going in the same direction, so I can't just add these two numbers. It's going to be a little bit less. Okay, so one more thing to do, and that's to find the direction. Well, let's think about this resultant force. Negative 19. This is going to be, and let me just draw this in another. We have a distance of 1947, or negative 1947. This is the length in the x direction. 602 is this length in the y direction. Well, it then stands to reason that this angle is going to be the inverse tangent of 602 over 1947. And put that in the calculator, and that's going to be about 17.2 degrees. Okay, so now 17.2 degrees, that's this. Of course, I want to... Remember, we're starting here at 0, so I want to find this angle. I just found this angle is 17.2. I want to find this angle, so I need to subtract that from 180, and that's going to give me the resultant angle of 162.8. And of course, I could also express this as 17.2 degrees north of west. It's another way of looking at it.